Okay, first, any questions on the homework? After I did the example for you, questions or no questions?
72.
Because we're going to have a quiz on this next week, yeah? So look at the schedule. I only meet with you how many times next week? Oh, we only meet twice next week. So the quiz is going to be Thursday. There, let's write it. Quiz Thursday. Double extended next week. Somebody said 17? Was that even a sign?
No,
70.
Or 70. 7. This is just like the other one we had. So 5 to the x squared plus 8 is equal, what?
72.
72. 9 to the 2x times 27 to the x squared. Hey, this looks like the quiz problem. 3 to the negative 1. All right. The only way you can solve this right now is you have to make a common base, right? What's the common base for 9, 27, and 3? So you write all the numbers with the base of 3. So 9 is the same thing as 3 squared, right? 27 is the same thing as 3 cubed, and 3 is 3. And then what do I do with the exponents when it's outside the parentheses? It rhymes with multiply. You multiply them. Same thing here. You multiply them. And then now that you're multiplying, what do you do with the exponents? You add them. Okay, PSAT, SAT, ACT all coming up. We got properties of exponents is on every single test. And then if 3 to the gorilla equals 3 to the banana, gorilla gotta equal banana. And then you just solve that equation. So whatever equation you get at the end, you just solve it. Well, this is a quadratic equation. Do we know how to solve that? Yeah, you make one side 0, and hopefully it factors, otherwise you gotta use the quadratic formula. You get 101 plus and plus. Yes, it factors very nicely. So x equals negative 1/3 or negative 1. Can do. You just gotta know when to multiply and when to add the exponents. I think we went over that many times. Is that it? What about the word problems? I did one of the word problems for you yesterday. Do we need to do another? Because I'm sure you're gonna have one. That means you gotta have a calculator now for the next quiz. Graphing doesn't have to be graphing calculator as long as you can punch in the numbers.
Phone calculator.
What?
Phone calculator.
No, not phone calculator. Like if you're taking chemistry, don't you have to have a regular scientific calculator? Yes. I think it's required for the class, so just bring that in. Or just borrow from your friend or something then. So no other questions? Good then. So yes, there will be a practice quiz. I'll put it up, since it's on Thursday, I'll put it up on Tuesday then. I can't believe we're only meeting 2 times next week. It's ridiculous. Maybe I should put it up before Tuesday so we can actually, no, never mind. You guys gotta do it. Okay, now if you look at the assignment sheet, we're gonna spend 2 nights on 6.4, and now we're gonna learn logarithms. I mentioned the word before, you probably didn't know what the heck I was talking about. Okay, but now you gotta know. What is a logarithm? Okay, so here we go. Suppose I ask you to graph this, and you already did this for homework. How do you graph y equal 2 to the x squared? Over the 3 points I told you what? Negative 1, 0, and 1, right? Okay. What happens when you plug in negative 1? You get half. 0, 1, 2, and then go like this. Remember, as the graph goes out to the left, the x-axis is a horizontal asymptote. But as you go to the right, the thing explodes out to infinity very quickly like that. Now, what if I were to tell you to graph the inverse of this? That's why we learned inverse in this chapter, because now it's all going to be pulled together. How do you graph the inverse of this? You did it on your quiz. You switch the x's and the y's. So what are the coordinates of this point? -1/2. So what happens when I switch them? 1/2, -1. What are the coordinates of that point? 0, 1. So if I switch it, you get 1, 0. What are the coordinates of this point? 1, 2. Switch it. So you get 2, 1. So the inverse looks like this. Oh, I missed. And again, anytime you graph a function and its inverse, it's going to be symmetric about the line y equal x. It is. Okay, but now, what is the equation of this graph? How do you find the equation of the inverse graph? Well, what did we do on yesterday's quiz? If this is the equation, how do you find the inverse? You switch the x's and y's. So you're going to get x equals 2 to the y. And then you need to solve for y. Okay, but how the heck do you solve for y? What do you do? Yeah, we've never seen anything like this before. So what somebody had to do, somebody had to invent new notation. So back in, I think it was the 1600s? I don't even remember already. Anyway, these two guys from Scotland and England, Napier and Briggs, they said, to solve for y, this is what you have to do. Y is equal to log base 2 of x. They just made up some notation, and that's what we use today. So in other words, we use this log, this is short for logarithm, to solve when the variable is in the exponent. Okay? So if somebody were to ask you, what is a logarithm? Then you just simply tell them, well, it's the inverse of an exponential function. That's what a logarithm is. Now, the key to working with logarithms is right there. You have to be able to switch back and forth between these two. This is called exponential form. This is called logarithmic form. If you can switch back and forth between the two, then this chapter will be very not difficult. So tonight's homework, that's pretty, you don't even have to worry about graphing tonight, because graphing is actually going to be in the second part, but I use it to explain because it's the inverse, yeah? So this is what you have to be able to do. If you see log base b of a equals c, see this is logarithmic form, then what does that mean? You switch it to exponential form. Okay, so what does this mean? See, this and this mean exactly the same thing. So how would you switch from log form to exponential form? This means the same thing as b, look, you see the 2 here? 2 to the y equals x. So 2 to the y equals x. So when you see this, this means b to the,
C.
it's a 1 out of 2 chance, c equals a. You just have to switch back and forth between the two. And then if you see this, okay, here, let's do another one. What if, okay, let's use different letters. What if you had m to the k is equal to w? Okay, that's called exponential form. How do you switch that to logarithmic form? That's the same thing as log base. Okay, thank you. M of w equals k. If you can switch back and forth between the two, it's easy. But that's what you have to practice. That's why you have the homework. Now, when you have, not all the graphs are going to be 2 to the x or log base 2x. What if you just had a number like b? I'll call it b for base. Then over here, this would become log base b of x. these two graphs are inverses of each other. And what did we just learn the last week? If two graphs are inverses of each other, or two functions, what happens when you plug one into the other one? Yeah, you'll always get the same answer, which is x. You guys remember that? If you have a function and it's inverse, and you plug one into the other, and it doesn't matter which way, you can plug the inverse into the function, or the function into the inverse, you will always get the same result every single time, and the answer is x. That's why we are learning it in this chapter. So, since this and this are inverses of each other, if you plug this into that, or that into that, the answer is going to be x. So let's do that. I'm going to write that down. So if I take this and plug it into there, you get b to the log base b of x. What is that equal to? We just talked about it before. If you have two functions that are inverses, if you plug one into the other, the answer is going to be x. And then what if I took that and plugged it in there? Then you would have log base b of b to the x equals x. So I'm going to box that because you're going to be using that on tonight's homework. So like for example, one of your problems on tonight's homework is going to be this. What is 5 to the log base 5 of 7? Here, I'll give you a hint. Look at that one.
Log C.
It's 7! Look, b to the log base b of x is equal to x. All I did is b is 5 in this problem, and x is the 7. Oh my, okay, maybe we gotta do another one. What is 3 to the log base 3 of 10 equal to? 10. See, it's easy. And the reason why is because they're inverses of each other. And then, okay, let's do this one. What is log base 4 of 4 to the 3rd power equal to? Here, look at this one. 3. Okay, I think we better do another one. What is log base 6 of 6 to the 5th power equal to? 5. And why? Because they're inverses of each other. Okay, so like I said, tonight's homework, if you can switch back, here, I will box this. If you can switch back and forth between these two, the problems are really, really easy. Okay, so let's do some examples from the book now. In fact, why don't I do one example from each section? In fact, let's take out the book already. Okay, what's the lowest number that you have on tonight's homework?
9.
Number 9, 13, 15. I bet you they all came from the same section? Yep. So why don't I do number 10? Look how easy this is. But of course, this is the kind of stuff you got to do when you first learn it. 16 is equal to 4 to the 2nd. They want you to change this to logarithmic form. Okay, so how would you change this to logarithmic form? Log base, or should I keep the thing up here? You know what? I'll keep it up here. If you have log base b of a equals c, that means the same thing as b to the c equals a here. I'll leave it up there. Okay? So change this. This is like the bottom one. Okay, so that's the same thing as saying log base 4 of 16 equals 2. That's all you're going to do. You got 3 problems like that. Hopefully after the 3rd one, you're pretty good at it. Okay, and then the next 3 problems, what does it say? I don't even know where I'm looking. 17, 21, 23. They give you log form, they want you to change it to exponential form. So I'll do number, no, that's ugly. I'll do number 18. Number 18. Log base 3 of 1/9 is equal to -2. Change that to exponential form. How do you do that? Follow that thing right there. No. 3 to the -2 equals, yeah. That's all you gotta do. And you got 3 problems where you gotta do that. And then the next 3 problems is 33. Find the exact value. Okay, so why don't I just do some of these? I'll do the even ones. 26. log base 8 of 8. What is that equal to? Okay, let's say, okay, I don't know what this number is equal to. Call it x. Okay?
8.
Change it to exponential form. This means the same thing as 8 to the x power equals 8, right? So think about that. 8 to the what power equals 8? 1, that's right. Now hopefully after a while, when you get used to this, you don't even need to put the x there. So when you see this, in your head, you're just thinking 8 to the what power equals 8. In fact, here, let's do some drills. Log base 2 of 8. Okay, let's not even put the x there. 2, so in your brain, you're thinking, oh, you're good already. 2 to the what power equals 8? 3! Isn't 2 to the third seed? Because if you change this to exponential form, 2 to the third power equal 8. You gotta know, you guys know your powers, right? I don't know. Let's do another one. Log base 3 of 9. So, okay, so this is what you think in your brain. 3 to the what power equals 9. How is it 3?
I was just thinking.
3 to the third power is 9? No, it's 27. 3 to the second power is 9. I think we gotta do some more. Log base 5 of 125 is equal to what? 5 to the what power equals 125? 3. Okay, that's all. Okay, let's just do one more. Log base 2 of 32 is equal to, so in your brain you think, okay, 2 to the what power equals 32? Very good, 5. Right? 2 to the 5th power? 2 times 2 times 2 times 2 times 2. Okay, that's all well good and easy, but then now, what happens if you have like this? Log base 4, this is a tougher one. Log base 4 of 8 equals what? So 4 to the what power equals 8? See, these were easy because the answers were whole numbers, but what happens if it's not a whole number? Like you get fractions or you get negative numbers. Okay, so obviously we don't have it. We don't have the answer. So let's just call it x. So change it to exponential form. 4 to the x power equals 8. 4 to the what power equals 8? Hey, Mr. Park, this looks like the problem you gave us the last couple nights. How do you solve an equation like this? You have to make a common base. What's a common base for 4 and 8? 2. So you gotta go. 4 is the same thing as 2 squared. 8 is the same thing as 2 to the third. And then you use your properties of exponents. What do I do with the exponents when it's outside the parentheses? It rhymes with multiply. You multiply them. And then if 2 to the gorilla equals 2 to the banana, gorilla gotta equal banana. And then finally, x equals what? 3 over 2. Oh, so 4 to the 3/2 power is equal to 8 then. See, so it's easy to do it in your head when it's a whole number, but not all the time it's going to come out to a whole number. So then you got to do this. Oh, so that's why we did that homework, Mr. Park. So when we come to this stage here, we know what to do. Yeah, exactly. That's why you did it. Okay, and then you have to go up to, am I looking at the right place? Up to 45. Oh, ho, 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 ho. Okay, it says find the domain. And don't be surprised to see the number e again now. Oh yeah, I guess I better mention the e thing. What if you had the base e? See, when you have log base e of x, maybe I shouldn't even use x, but that's okay, I'm just going to use it because x can be anything. We don't write log base e. We write natural log x. You have to get used to that. So when you see natural log x, that's what this thing means, natural log x. That means the base is e, but we just don't write it. You just have to get used to that because that's how we do it in calculus. And same thing with base 10. When you have a base 10 logarithm like that, we just write it like this. So if you ever see a logarithm with no base here, that means it's 10. It's just that we don't write it. That's because humans have 10 fingers. That's pretty much why. And then if you see natural log, that means the base is e, but again, we just don't write it. So you have to get used to that. Okay, so we call this a common logarithm because it's common. We have 10 fingers, right? This one is called a natural logarithm. That's why natural log. ln, natural log. Okay, so like on tonight's homework, you're gonna have this, or I'll give you one. I'll do it. Natural log of e cubed. Okay, here's 36. Compute this. Natural log of e cubed. What is that equal to? Okay, let's call that number x. Mr. Park, I don't know what that number is. Okay, well, what is natural log? It's log base what? E. E to the third equal x. So if you need to write that, you write that. Natural log means log base e. So once you have this, change it to exponential form. This means the same thing as e to the x equals e to the third. So this one's pretty obvious. What does x have to do? X got to be 3. So this number is 3. So again, the key to working with logarithms, you just switch back and forth between these two. Okay, and then the last set of problems, you have to find the domain. Now, oh darn it, I erased it. That's okay, here. Let me put the graphs back up here, the ones I had. Darn it, why did I erase it? It's kind of dumb. Wow! That's what a typical exponential function looks like. And this is what a typical logarithmic function looks like. It's like that. And they're symmetric about the line. So this is y equals log, what am I saying? 2 to the x. And this is y equals log base 2 of x. They're inverses of each other. Now look at the first graph, this one right here. What is the domain? Let's find the domain and range of each one. What is the domain of this first graph? If I were to list out all the x coordinates, what would you have? All real numbers. What is the range?
Greater than 0.
Yeah, because the thing gets closer and closer to the x-axis, but it never reaches there, right? So it's greater than 0. If you rather write y is greater than 0, you can write that too. Okay, so on the inverse, what would be the domain and the range? Well, there's two ways to do it. Look at the graph. What is the domain? If I were to list every single x coordinate on this graph, what would it be? X would gotta be greater than 0, right? It would be 0 to infinity. And what is the range? If I were to list every single y coordinate on this graph, what would you get? All real numbers, right? Hey, Mr. Park, it switched. Exactly. When you have a function and its inverse, all the x's and y's get switched, which means the domain of the first one is the range of the second, and the range of the first one is the domain of the second. They just got switched, because that's how you find the inverse. Anyway, this is the point. Whenever you have a logarithm like this, what was the domain? X is greater than 0. So whenever you have a logarithm, this thing has to be greater than 0. I'll just make it simple for you. If you see log something, this something, whatever it is, has to be greater than 0. It has to be, because that's what the domain is. So on tonight's homework, you have to find the domain of certain functions. So here, I'll just give you some examples. So they give you a function like this, f of x. I'll start off with an easy one. Log base 3 of x minus 2. What is the domain? How do you find the domain? Well, whatever you see here, you just make that, I just taught it to you, greater than 0. Because whenever you have a logarithm, this thing, this is, by the way, this is called the argument. This argument has to be positive. It has to be greater than 0, otherwise it doesn't make sense. So whatever you have here, just make it greater than 0, and if you solve it, that will tell you the domain. So how would you solve an easy inequality like this?
Subtract
Add 2 to both sides, and so you get x is greater than 2. That's your domain. But of course, you should, remember I told you that domain is a set, so you should write it as a set. However, since for algebra 2b, if you just wrote x is greater than 2, I'll give you credit. Okay, but then of course, then you get the harder problems. Too bad I'm erasing this. Okay, last example, we're almost done. F of x is equal to natural log of x plus 1 over x minus 2. Now, don't get scared with natural log. That just means log base e, right? And what is e again? 2.7, right? It's just a number. Okay, so how do you find the domain? Well, whenever you have a logarithm, this thing has to be what? Greater than 0. Just write that on your paper. You get 1 point. Now you got to solve that. Now, do we know how to solve inequalities that look like that? Yeah, that was the last test we took. How do you solve inequalities again? You make one side 0, it is. You factor this side, it is. So once you have that all in place, what do? You make a number line. What goes on? Why do you think we learned it last chapter? So we can just forget about it? Who said that? What do I put on the number line? What makes the top 0? What makes the bottom 0? Okay. How come they're both not part of the solution? Because it's just greater than, it's not or equal to. So. And then when you test it, think of a number bigger than 2, like 3. Plug it in. 3 plus 1 is positive. 3 minus 2 is positive. Positive divided by positive, positive. And then how do I know they're going to alternate like that? Because they both have odd powers on it. Remember that from last test? Or let's just say you purged everything already. Let's just pretend you forgot everything. Then what do? Think of a number between -1 and 2, like 0. Who said 3? Who said 3? 0. 0 plus 1 is positive. 0 minus 2 is negative. Positive over negative is positive divided by a negative is negative. I think you better just look at the powers. And then now, this is for the people that don't know the pattern. Okay, then think of a number smaller than -1, like -2. Plug it in. -2 plus 1 is -1, right? -2 minus 2 is -4. Negative divided by negative is positive. Thank you. Now, which one do I shade in? Because some of you on the last test got confused. Do I shade in the plus ones or the minus ones? Yeah, because if it's greater than, you shade in the plus ones. If it's less than, you shade in the minus ones. So what is the domain of this problem? X is less than -1, or x is greater than 2. And if you want to be mathematically correct, you write that. Or how about just write this? Negative infinity to -1, and then from 2 to infinity. So just remember, whenever you have a logarithm, this thing, whatever it is, it doesn't matter what it is, it has to be greater than 0. Okay, so tonight's homework, once you can go back and forth here, it's really not that difficult. And then when do I see you next? Where is it? When I see you on Tuesday, then you're going to have to be responsible for the graphs. And then you're going to shift them left, right, up. It's not that difficult. All right, I'm going to give you the rest of the time, which is 22 minutes. Hey, I got a good idea. Why don't I finish my homework now, and then I don't have any homework over the weekend? Yeah, well, Mr. Park, we're not meeting till Tuesday, so I'm cruising till Tuesday morning. Yeah, but then are you going to remember how to do these problems Tuesday morning? Nope. Yeah, because the video is going to be posted, and then you can watch it.
Oh yeah, actually.
Oh, you guys are reading for it, huh? Or am I reading your one? All right.